Hello students, I hope you have gone through the physical and chemical properties of both acid and bases. You have already seen that acid can be classified into strong acid and weak acid according to their dissociation. In strong acids we find there is a complete dissociation of ions, whereas in weak acid we find a partial dissociation. Similarly, in case of bases, we have also observed that strong bases they get completely ionized in water, whereas the weak base they partially ionize. Now let us see what happens, what are the ions present when acid and bases are dissociated in water. So let us take one example, say HCl. When dissociated in water, it gives H plus and Cl minus ions. Moreover, we know HCl is dissociated in water. So the water molecule also dissociate to give H plus and OH minus ion. Okay. Now let us take a base. NaOH dissociates into Na plus and OH minus. We also know that base is also dissociated in water, so the water molecule will also dissociate. H2O dissociates into H plus and OH minus. Now we have seen this is the dissociation of acid. In water, and this is the dissociation of base in water. Okay, so in both the cases we observe that we obtain H plus ions in common. We get H plus ions in common. So either it is an acid or it is a base, both dissociates H plus ions. The H plus ions in case of acid is dissociated by both the acid and the water molecule, whereas in case of base only the water molecule leads to the dissociation of H plus ions. There was a scientist who calculated this particular concentration of H plus ions present in different substances, whether it is an acid and base, and depending upon the concentration of the H plus ions, he calculated a scale which is called the pH scale. Okay, the scientist's name was Sorensen. He calculated a scale which is called the pH scale accordingly as the minus logarithm of the H plus ions. Now we know that acid will dissociate in larger amount, giving larger amount of H plus ions, whereas in case of base we will have least amount of H plus ions. So let us take the hydrogen ion concentration in acid is more. So here the value of the hydrogen ion concentration of acid will be more than that of the base, and hence because of the negative sign the pH will be less. More the hydrogen ion concentration, less will be the pH, and less the hydrogen ion concentration, more will be the pH. So in the particular scale he classified them into 14 divisions, whereas there is a midpoint which is 7, starting from 0 to 14. The substances that will have a pH below 7 will be termed as acid, and the substance that has a pH above 7 will be termed as base. Now in this particular scale we can see equal divisions. Okay, and these divisions are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So in this scale we know the scale of pH ranges from 0 to 14. Okay, now in this scale only we can identify the substances that will have a higher concentration of H plus ions are the strong acids and will take a position over here in the scale. So the substances having pH 0 to 3.5 will have a hydrogen ion concentration more than any other substances, and hence they will have a least value from 0 to 3.5. Then we have weak acids. They also have hydrogen ion concentration considerably greater than that of bases and will have a pH from 3.5 to 6.9. And there are some substances also that have a pH that is 7. These substances are neutral. These substances are neutral in nature. They doesn't have acidic behavior nor they have a basic behavior. The substances that will have pH value more than 7 to 10.5 will be termed as weak base, and the substances that will have a pH above 10.5 till 14 will be called as strong base. So depending upon the pH, we can classify substances like acid and bases into strong, weak. Okay. Now let us recapitulate the particular part. What we have studied in the strength of acid and bases that are classified into strong and weak depending upon their complete and partial dissociation respectively. We know that in both dissociation of acid and bases, we find there is the H plus ions present in the solution. There is the H plus ions present in the solution. In case of dissociation of acid, we find that the H plus ions are obtained from both the acid molecule as well as the water molecule. But in case of dissociation of a base, we find only the water molecule to give the H plus ions in the water, H plus ions in the solution. So we can say that acid will have a greater number of H plus ions, whereas bases will have a less number of hydrogen ions. A scientist named Sorensen, he calculated the hydrogen ion concentration and found out the pH, the power of hydrogen of substances. Okay, now we can see he calculated pH as the minus logarithm of the hydrogen ion concentration. So more will be the hydrogen ion concentration, less will be the pH value because of the negative sign, and less will be the hydrogen ion concentration, more will be the pH value. Okay, accordingly a pH scale ranges from 0 to 14. Clear? Now the substances that are below 7, the substances that will have a pH below 7 are termed as acid. Okay, in this particular part of acid we can see the substances that will have a least pH value are strong, and a substance having pH value more than 3.5 to 6.9 are termed as weak acids, whereas substances that have a pH 7 will be called as neutral, Moreover, the substances that are having a pH beyond 7 will be called as bases, and accordingly we will term them as weak base and strong base. Let us name one of each of them. Okay, now let us talk about strong acid. Strong acids include your H2SO4, I hope you remember, sulfuric acid, HCl, hydrochloric acid, HNO3. Okay, these are the strong acids having range from 0 to 3.5. Whereas if you talk about weak acid, this is CH3COOH, CH3COOH. Okay, we can also have lactic acid. Now in a weak base, we know it is NH4OH, ZNOH whole 2. These are weak bases, whereas NaOH is a strong base, KOH is a strong base. Clear? Now this particular pH scale 0 to 14, okay, the substances can have any of the pH scale. Now there is a special indicator which is called the universal indicator, okay, that is a mixture of several colors, okay, that when dipped in a particular substance give a change in color. Okay, now the very important part of universal indicator is that it gives different color for different pH value. Okay, let us talk about the pH universal indicator. Now, universal indicators are a special type of indicators that give different color for different value of pH scale. It is a mixture of colors. Now let us see what are the colors they give. Now when we have a particular pH value 0, a universal indicator gives different color for different values of pH scale. I am not providing you the different colors, but I will give you the colors. Okay, I cannot show you the colors actually. Okay, over here because I don't have different markers. Okay, so let us see what is the color of the universal indicator when it is 0. So it will be red, dark red. Then the red becomes a little light, so we write red. Then we write, in case of pH value 2, it will be pale red. Then the red color slowly becomes orange, so we write orange red. Okay, then slowly it turns orange, then it becomes orange yellow, then yellow, then the particular 7 neutral substances will have a green color, okay. Now when we will talk about bases, the color will change from greenish blue to sky blue, then it will become navy blue. Okay, in case of 11, the color changes from blue to purple, dark purple. This is violet and this will be dark violet. Okay, now let us say what is universal indicators. In case of universal indicators, we have seen these indicators give different color for different pH scales. So with the help of this universal indicator, we actually can determine the pH of a particular substances. In case of the previous indicators, we just could determine whether a substance is an acid or it is a base. But in case of universal indicators, we can classify substances whether it is a strong base or a weak base, or it is a strong acid or a weak acid, depending upon the color. Now let us see the color. When it is a strong acid, it is red in color, quietly red in color. Okay. Now when it is becoming a weak acid, it turns to orange to yellow, and neutral substances will have green color. Then we will talk about weak bases. The green color changes to slightly blue, to sky blue, to navy blue in case of weak bases. And then in case of strong bases, the color changes to purple to violet. Okay, so this was all about your pH scale and the strength of acid bases depending upon the pH. We know that the pH of a particular substance is the negative log of H plus ions. This particular equation has to be understood very clearly. Okay, as it is the negative log of the H plus ions, even though strong acids liberate a higher concentration of H plus ions, they have least value of pH because of the negative sign. Whereas strong bases, they liberate very less number of H plus ions, and hence they have the greatest value of pH in the pH scale. The pH scale is ranging from 0 to 14. Okay, and depending upon universal indicators we can actually understand a substance is a strong acid or a weak acid, or it is a strong base or a weak base. So this was it for this part of the video. In the next video we are going to learn why is pH so important for our day-to-day life. Okay, thank you so much. Please go through the videos. If you have any problem, please comment in the comment section. Thank you.